Hello, welcome to an algebraic word problem. We're going to try to use algebra to set up and solve this problem. We see that a pharmacist needs 30 grams of a 4% lidocaine cream. He has none in stock. He decides to mix his own. He uses 5% lidocaine cream and 3% lidocaine cream, and we're asked how much of each type he should use. We've previously talked about that we typically need variables to represent the quantities that would answer the question. And so this question asks how much of each type, and so I'm going to need a variable to represent the x and represent the y. Value, and they're going to be the 5% and 3%, but it starts to get all confusing because there's so many percents. So let's start with a picture, and then we'll try to draw this out. So my first picture. The pharmacist wants 4% lidocaine cream. That's over here on the right-hand side of your screen, and it's out of stock. And he's going to mix his own by mixing 5% and 3%. So I have a plus sign between them because he's mixing them. So in my mind, I'm viewing this as a mixture problem because he is mixing things together. And for me personally, when I have a mixture problem, when there are three percentages involved, like there are here, 5%, 3%, and 4%, it is helpful to me to draw containers. And those containers just represent the different parts that I have pictured down here. So add in some containers. So in my container, I'm putting the same information as that I have on the picture, but I don't have pictures of lidocaine cream or whatever for every problem. So in this first one, this bucket or container represents my 5% cream. There's the plus sign because I'm adding these two kinds together. This represents the 3% cream. And this big container is when I have them both mixed. I'm trying to make 4% cream. Next, I also need to know how much is in each container. So the percentages really are serving as the value, but I need to know how much do I have at that value. So the question asks me how much of each type should he use. So my two types are 5% and 3%. So I'm going to put x and y. And I'm using this as instead of writing out a statement, let x equal the 5% cream and let y equal the 3% cream. So by putting them in the same container, that defines what those stand for. Now, it tells me the pharmacist needs 30 grams. So I do see this as a total, the total amount that he needs. And that's this big container because 30 grams. So this one needs 30 grams. So that tells me that I'm going to measure these others in grams as well. And I didn't get images that have all of the labels on, but I do see on this first one, like this is 30 grams worth of this cream. So we have a good many grams available to us. Now, I still have to use the concepts from before, so I need an items equation. And my items in this case are the grams. Because that's what I'm measuring, how many grams, how many grams. And so I see this row of my image being the items equation. So I get x plus y is going to add up to 30 grams total. And then I also need a value equation. And the percents go with the value equation. So each percent has to be changed to a decimal. So I'll take 5 over 100 is 0.05. I'll take 3 over 100, 0.03. And 4 over 100 is 0.04. So how much of this first vat of cream is actually lidocaine? Well, 5% of it. So its value is 0.05 times x. That's the amount, that's the actual lidocaine. In the second one, same idea. In this container, only 3% is lidocaine, so 0.3 times y. But in our final container, there's still only 8% of it that is the active ingredient, the lidocaine. So what I have to do is I have to use the percent here, so the 0.04, and this time the amount is known to be 30 instead of a variable. So these are my two equations, and I'm going to take them to the Desmos graphing calculator to solve. So pull my calculator. It's hard to see both my calculator and my equations, but let's type it in. So our first equation was x plus y equals to 30. Our second equation, we had 0.05x plus 0.03y is equal to 0.04 times 30. All right, so have them typed in. I want to see where they're at, so I'm going to scroll down with my mouse, and I find them pretty quickly. Center them up here a little bit. So two lines, red and black this time, intersecting. So click on them, and I get ordered pair of 15, 15. So if I use 15 grams of each kind, I will get 30 grams total, and my total will be at the 4%. So going back to our problem, when we solved it out, we got 15, 15 as our ordered pair. We know that ordered pairs are alphabetical, so X and Y. And then taking it back to the containers that we have, in this first one, the 5% container, we would have 15 grams. And in the second one, in the 3% container, we also have 15 grams. And we can clearly see those that add up to 30 grams, so that checks. And we can also see that 4% is right in the middle of 5 and 3. So it makes sense to me to have an equal amount of each one so that I end up directly in the middle.